Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's see how you did on the first few problems of this 10.1.5 homework. I've split it up into two parts. So the first part has your M&Ms for the volume of a sphere. Remember, the sphere has a center point. It's a three-dimensional circle, so the radius is the distance from the center point to the sphere itself, but in 3 dimensions instead of 2 dimensions like a circle would be. The volume of the sphere is 2 times the volume of a cone with the same radius and the same height. Yeah, we talked about this a little bit last week, but just in general, that's the formula that we are applying. We derived that formula last week. So once you know what the radius is, plug it in, cube it, multiply times 4/3, then multiply times pi. You can technically multiply them in any order that you want. And then label your answer in cubic units. So find the volume of a sphere with a radius of 620,000 miles. All right, write your answer in scientific notation. Wow, this is good. Okay, so let us, I think we just do the work here. And oh, that looks like a horrible mess. But this is a problem where it might be a good idea actually to use your scientific notation. Since this is in the 100,000ths place, that's going to mean that the radius is 6.2 times 10 to the 5th power. So that quantity is the radius which gets cubed, which means it's going to be 6.2 cubed times 10 to the 5th cubed again to make that 10 to the 15th. And then, of course, you've got your 4/3, which in this particular situation probably is going to be better for you to just treat the 4 and the pi and the r cubed in the numerator together. So you could actually solve this and then divide by 3. Another way that I've done it is instead of doing 4/3, it's 4 divided by 3 is equal to 1.3 repeated. I've taken, like, I'm just going to put a random number there. 25 times 4/3 would be times 1.333, and just keep pressing that button as far as you can get it to go. That will give you a pretty accurate answer. But the best way to do it is 25 times 4, get that answer, and then divide by 3. Same thing. So you can do it either way, doesn't matter. All right, so we start with our radius in scientific notation, plug it in here, use that whole power of a product property so that this 3 applies to both the 10 to the 5th and the 6.2, and then just start multiplying everything straight across. So I think what I'm going to do is this part here. Figure out what that is, and then multiply it times 10 to the 15th. Or maybe, now let's just figure out what this is first. First of all, what is 6 cubed? 6.2 raised to the 3rd power is 238.328. Now, to make it a little easier, I think I'm just going to multiply it times 3.14 instead of the pi button. So times 3.14 is equal to that. Then multiply that times 4, which gives you this, and then divide that number by 3. So this ends up being 997.8. 997.8. And then that's going to become times 10 to the 15th power. Well, this is not scientific notation, remember? We've got to have this leading factor be a number between 1 and 10. Less than 10 though. So the first digit is a 9, so it's going to become 9.978. And since we are basically dividing that by 100, let's take that 100 as a power of 10 and move it over to here. So that's how this is going to become 10 to the 17th power. I rounded this here in my answer to 9.98, but you could have left it like that and it would have been fine. So these are the types of problems where using scientific notation actually kind of makes this a little bit easier rather than keeping track of all those zeros. Because honestly, What is 620,000 raised to the third power? See if the calculator will even show that. 620,000 raised to the third power. Well, maybe that'll fit in there. Now you multiply that times pi. Then you multiply that times 4. Then you divide that by 3. And yeah, good luck converting that to scientific notation or writing that out. So honestly, understanding how scientific notation works and using your exponent rules to solve this problem does make life easier once you know what you're doing. All right, find the volume of the cone. Remember, the volume of a cone is 1/3 the volume of a cylinder that has the exact same base area and the exact same height. So instead of base area times height, we're going to take 1/3 times the base area times the height. And the base area is that of a circle, so we're going to change that to pi r squared. So in this case, pi being 3.14 and the radius squared is 64 and the height is equal to 20, you can go ahead and figure out what the area of the cylinder or what the volume of the cylinder would be, then take 1/3 of that by dividing it by 3. That's kind of what I did there. So we end up with this as our answer. Now, if you had chosen to use pi, you probably got something close. Let me do this again, where we take 64 times 20 and then multiply that times this pi and then divide it by 3 because that's what happens when you take 1/3 of it. And then my answer for that was a little bit more, 1,340, which that would round up to 1,340. So you probably recognize that they're so close to each other that if you didn't use this pi, you use the pi button, you still got the answer correct. Graphing. Graph the points that are shown here, and that's what I did here. You got 0, 2, you got 1, 4 here, you've got 7, 4 here, and you've got 6, 2 here. What is the perimeter of this parallelogram? Well, we know these are 6s because you can count 1, 2, 3, 4, 5, 6. But how do you figure out what the length of that is? Well, that's a hypotenuse, isn't it? So we have to use the Pythagorean theorem to figure out these two diagonals. So a squared plus b squared is going to be equal to c squared. So 1 plus 4 is 5. The square root of 5 is 2.34 approximately. That means that each one of these sides has to be 2.34. So you add them all together and you get something that's roughly close to 16.68 units. Do they even tell us what the units are? No, they're just units. All right, simplify each of the following expressions using your exponent rules. Remember, the exponent applies to whatever it touches. So this 2 applies to everything inside the parentheses. So it becomes 5 squared times x to the third raised again to the second power. And then when you do power of a power, remember you multiply the exponents, because if you were to expand this out, that's x to the third, but you need 2 of those repeatedly multiplied together. You can literally see that there are 6 x's repeatedly being multiplied. When we are dealing with division, we can separate these into their different parts. So you got your 14 over 21 here. You've got your a to the third over a to the fourth here, and then you've got your b squared over b to the third. So after simplifying, this simplifies down to 2/3. This simplifies down, if you cancel out all the a's on the top and 3 of the a's on the bottom, is 1 over a. And then this simplifies, same thing. You cancel out all the b's on the top and 2 of them from the bottom, which gives you 1 over b. Now you could choose to write it this way, which eventually becomes that, or some people might have chosen to take the fractional part and say 2/3 and then a to the negative first, b to the negative first. But that, I really don't like writing it that way. I think this is a better way to write it. Always have your exponents with that are positive. That just seems easier to understand for everyone. And then the final problem, you take your numbers, they can be multiplied together, so your 2 and your 3 get to be multiplied together. Then your m to the third times m to the first. How do I know that's m to the first? Because if there's no exponent, you know it's understood to be to the first power, and then n squared times n to the fourth And these guys, just multiply them together to give you 6. Those, whenever you're multiplying powers together that have the same base, you keep your base and you add your exponents. So that's m to the 4th. And same thing here, keep your base, add your exponents, and that is your simplified version. All right, so you've been working on your glasses task. I have posted a new video that kind of gives you a little bit more guidance, gives you a little bit more of a nudge. That problem C is confusing, but I'm not going to give you the answer to it yet, but I will point you in the right direction for that. And tomorrow I will post all the answers so you can see how well you did. All right, so go back to the glasses task if you haven't already finished it. Even if you have finished it, I'd recommend you look at the video just to see if maybe you're on the right track. Maybe you made a mistake somewhere and I can point you in the right direction and you can go back and fix it. All right, take care. Bye.
Hey, feeling